Hi, Assalamualaikum. My name is Muhammad Shafwan bin Anis. My metric number is 231061515112. So this is our my presentation for our case study, which is our title is a fuzzy decision making application for air conditioning temperature control. So we can see for all around the world, before this we have the temperature control, which is not using the fuzzy logic, but we are using the binary one. So which mean when we are going for the for example for air conditioner, so we have previously we have like a binary, so which when we are cold we turn on our air conditioner, and when we feel hot we turn off. So there is not much application we can use, not much variation that we can use to enhance our air conditioner. But for this project we are using a fuzzy logic to design our air conditioner, so we can have a variable of speed in case of variable of inputs. Okay, so let's move on to our MATLAB. So here is our fuzzy logic designer. So as we can see here um, at the graph here we have two inputs and also one output. All right, so we have like temperature and also the humidity, and then the output is the fan speed. So we can see here for the input we have the temperature, which is at the right side, which is the cold, comfortable and hot. Which is the cold is from the minimum for 15 degrees Celsius to 25 degrees Celsius, comfortable from minimum of 20 degrees Celsius until 35 degrees Celsius, and for hot is 30 degrees Celsius until 40 degrees Celsius. We also have the input for humidity. So here humidity we have the dry, normal and wet. So we have the parameter from 0 to 50 for dry, 50 to 25 to 75 for normal, and also 50 to 100 for wet. So for the output, we design our output as the fan speed. So we have the fan speed of low, medium and also high. Alright. So for the low we have the speed of 0 to 50. For the medium we have the speed of 25 until 75, and for the high we have the variable of 50 until 100. So that's our fuzzy input and output. All right. So in summary, our input and output is a hot, cold, comfortable for temperature, humidity for wet, normal and dry, and for output is low, medium and high. So let's jump into the rules of our fuzzy logic designer. So here, so we can see we have nine fuzzy logic rules. So which is the first rule is if the temperature is cold and the humidity is dry, then the fan speed is low. The second rule is if the temperature is cold and humidity is normal, then the fan speed is low. And also the third rule is if the temperature is cold and humidity is wet, then fan speed is medium. The fourth rule is if temperature is comfortable and humidity is dry, then the fan speed is medium. The fifth rule is if the temperature is comfortable and humidity is normal, then the fan speed is medium. The sixth rule if the temperature is comfortable and humidity is wet, then the fan speed is high. The seventh rule is if temperature is hot and humidity is dry, then the fan speed is medium. The eighth rule is if the temperature is hot and humidity is normal, then the fan speed is high. The ninth rule is the last rule is that if temperature is hot and humidity is wet, then the fan speed is high. So that's for our rules, and also and also we have discussed input output and also our rules. So let's go to the result of what we have done today. So here's our result. So here's our coding for the result. So we have this coding. So which we load our fuzzy logic designer here, and here is the our input, which is the temperature, cold, comfortable, and hot. And here the input of our humidity and also the output fan speed. So here's our rule, then our 9 rules, right? And here our testing. So we have to evaluate. So how we evaluate is to run this coding. So we can see that from the we have two outputs here, which is the evaluation result here, and also we have the surface view. So you can see. So let's go to the terminal first. For the evaluation result. So you can see for the test one, we have the temperature of 22, which is low, and also humidity of 40. We can see the fan speed is around 34.55. So if we high up our temperature, which is 28, and the humidity is we make it higher, which is 60, then we have the fan speed of 57 to 68. And then the humidity is low, so we can see that the fan speed is 61.13%. And the last one, if we ramp up our temperature to the highest, not the highest, but 36, close to the highest, and the humidity that the fan speed is highest, that one we can see, which is the 81.69%. So here we can see um, for our surface view. So we have the three variable, which is the fan speed here, and the humidity here, and also the temperature here. So we can see from this view, in summary, we can see if the humidity and temperature is higher, then it can lead to the fan speed to become high also. So at the bottom one is for the low temperature and humidity, and when it goes up it becomes more yellow and orange. So that means if the humidity and the temperature is high, then that means that our surface view is become higher, hotter. Then what it needs to become fan speed to become more speed, all right, more speed, okay, to increase the speed of our span. So that's all from me. Thank you very much.